In this video, we're going to cover our 5.4 under instruction pipelining. So what we're going to look is the overview, of course, the pipeline strategy, pipeline performance, but I guess we're going to be until here only for our 5.4 part A and 5.4 part B. I'm going to cover all of this, but also depend on how long it takes for me to explain for each video. I don't want to take it's too much long in one video, so I hope that you understand. I'm going to do part by part. So now we will look into the overview. What is basically pipeline? Is it pipe? So over here, organization enhancement to the process can improve performance with another approach, instructions pipeline. CPU break, fetch, decode, execute cycle into tasks that perform in parallel. So you're going to do it parallel. That's why you're going to learn pipeline model in high performance parallel data processing. That's why you're going to learn it in that subject, which is on something that parallelly done, so that more than one task can be executed at a time. Let's say you have, I name it as A. You have task A. You have task A, which is maybe you need to do writing. You need to write up your paper. So write up a paper, and while writing up a paper, what you need to do is, of course, you're going to do the whole paper. You're going to do one by one. Let's say abstract. After abstract, introduction, and then maybe you have a methodology, and then I just summarize its conclusion. So you have several parts. You write up your abstract. After finish, then you move to your instruction. After finish, you do the methodology. After finish, you do the conclusion. Normally, normal people will do this step by step. Once task finish, you do another one. One task finish, and then you move to another one. But throughout our pipeline, we're going to do it parallelly. While you are writing your abstract, of course, you're going to think about something. You're going to find out any related or relevant sentences for you to be putting inside your abstract. While also you are looking that, you will also take a look whatever information that necessary to be put into your introduction, or maybe you find out something that you can deal up and link it into your methodology or also your conclusion. It is parallelly run in one time, so you're going to speed it up. That is the most important things. So you can see, you execute it, you do it at a time which is parallel in the time. The concept of pipeline is allow the processing of a new task even though the processing of previous task has not ended. Means that you not yet finished writing up your abstract, but you already start writing up your introduction. Although you are not finish up your introduction, but you do your conclusion. So this is called as a pipeline concept. Easy to understand, right? Okay. Now, the analogy of your pipeline. So the example of your laundry. Anyone who has done a lot of laundry has intuitively use pipeline because there are a lot of closets and etc. To be clean. So if you did not use pipeline concept, you're going to face longer in time to finish. So this step is a normally people will do if there is no pipeline approach. So pipeline approach to laundry, which is non-pipeline, first you're going to place the dirty clothes in the washer. Second, when washer is finished, you place wet clothes to the dryer. After your dryer finish, then you go place the dryer load on the table and you're going to lipat, you fold it. When you fold finish, you ask your roommate to put the clothes away and you ask yourself lah to put your clothes away. Or maybe you go and bring your clothes back to your room and then you're going to put into your wardrobe. So that is the flow what is basically normally happen without or non-pipeline approach. So over here, the laundry in this picture, the laundry analogy. If let's say you have 4 loads A, B, C, D. You ada 4 for pipelining. So you have 4. And your task A, let's say you take the service for laundry people clothes from Ali, from Boy, from Chicha, from Didi. So you need to finish it one by one. Let's say you do the laundry from Ali first. You do the washer, you do the dryer, you do the folding, and then you're going to, let's say, wrap it in the plastic and send back to the Ali. Finish. After finish, you do another task which is for Boboy. Although you get at the beginning time, early in the morning, you get all these 4 order. Ali call you to do the laundry, boy call you for laundry, Chicha call you for the laundry, and Didi also ask you to do the laundry. But what you do with non-pipeline, you're going to do Ali order first. When finish, you're going to continue your boy order. Wash, dryer, folding, and then you're going to put it into the wardrobe. Same goes to Chicha, and then lastly, after you finish Chicha orders, you're going to do the Didi. So you can see you are doing it in order, step by step. After finish, then you continue. After finish, then you're going to continue new order. Non-pipeline, which is 16 unit of time. This is the duration maybe that you need to take. But if let's say you have the non-pipeline, so what you're going to do? You will do task A, which is Ali order. You watch, and after you finish watch, you're going to bring Ali clothes. After you wash, right, you're going to go to the dryer. So Ali clothes now in the dryer, and the washing machine is empty, isn't it? So because it's empty, you will bring this boy order to the washing machine. This is basically similar over here. So you start watch Ali while you watch Boboy while you are dryer your Ali order or Ali clothes. Okay, Ali clothes now here dryer and Boboy is watch, but there is no order can be done to your Chicha and Didi. Then Ali order finish, do the dryer. This one of course is automatic. Then you going to bring it to the folding table. You nak kena lipat. You going to fold all the clothes. While you move it, after you move, you letak, you put it into the folding table, and you going to start. You will see at this time, you're going to start check. Boy order finish already. Finish the wash. So your washer machine over here is empty. Allah, nak tekan pun susah ni. Eraser. Okay. Okay, so now your machines, because your boboy already done, right? Now you move it into the dryer. Boboy are doing the dryer. It is automatically you going to put it, and you're going to fold your Ali order while this washing machine is empty. So you're going to put your Chicha clothes inside. While Chicha doing wash, Boboy doing the dryer, and your Ali order you going to do the folding. After you done folding, next after you done folding, the dryer stop, the washer stop, you're going to put your Ali order, let's say, inside the plastic bag. Then you're going to ready to delivery to the wardrobe. Okay, of course, going to delivery to Ali. Because this is already finished, right? Then you're going to see the dryer. The dryer now is finished. Boboy, you're going to move it into folder. And then your Chicha finish wash, and you're going to move to the dryer. Now your washing machine is empty. You're going to put the Didi clothes inside your washing machine. See? Then while this all dryer washing machine is running, you do the folding all parallelly. After you finish, you're going to make it ready. You put inside a plastic bag, ready to be delivered to Boboy. This one is also already done. Ali order. All Ali clothes is already done. And now, Chicha finish dryer. You put into the folding table. Didi done the washing, then you put inside the dryer. While then you're going to fold your Chicha clothes, and then you finish. After you finish, you're going to put it into the plastic bag. It's ready to be sent to Chicha. And of course, the dryer already stopped. Then you're going to fold your Chicha clothes to be ready also. And you're going to finish it, ready to be packed into the plastic bag and to be delivered to the wardrobe of Didi. See how many times? How about the durations? How long it takes for you to finish if you are having the pipeline? Only 7 units of time. If compared to non-pipeline, you need to have about 16 units. It's more than 2 times longer rather than non-pipeline. Okay. So over here the laundry analogy 816 load for pipeline. So if let's say you are having 816 load. So non-pipeline, you're going to do task order times your task. How many tasks that you have? And then you're going to time with 4 because you have Ali, you have Bobo, you have Chicha, and you have Didi. And then after that, the total out is 3,264 unit of time if non-pipeline. Then if you are doing using a pipeline concept, your task will be using the equations of task plus task order minus 1. Because every single task, let's say task B, C, D, you're going to you're going to increase one time. You're going to do it parallelly. So your task, how many tasks you have? Still 4. Ali, Boboy, Chicha, Didi. That's why you put it 4. And then you're going to deduct your task order with 1. So everything will be deduct with 1. So that's why you will get 816 minus 1 equal to 815. But you can see this one is time because you need to wait until finish first. But it's going to be done it in parallel. So you're going to add plus. Later on you will see the equation. Wait my mom call. Hello. Adik lupa. Adik lupa cakap kat dia. Bayar online boleh cakap kat dia? No? Okey. Sebab adik lupa tadi adik tengah record video ni. Okey, bye. Sorry, my mom call. What happened? Okay. Continue. Okay. So, we continue. This one we already finished as I mentioned. Later on you will learn on the equation, how you're going to use it, going to apply it. So what type of equation later we will discuss. So we will learn it step by step. This one is for your example first, okay? Instruction pipeline. So under instruction pipeline, process, you can see over here, segment 3, segment 2, segment 1. Okay, you have a single instruction cycle process is divided into several small independent tasks, or we call it as segment. Let's say you have one long process. Easiest way is you do writing a paper. You need to do abstract, you need to do introduction, you need to do conclusion. So you can see you have long process, But what you need to do is you need to separate it into segment, into tasks. Going to separate abstract, introduction, and also conclusion. This is just example. Okay, some segment can be performed in parallel. Okay, you can perform this with this parallelly, but maybe conclusion you cannot do it parallelly. So depend on the segment also. Some, this one is some segment can be performed in parallel. You can do abstract with the introduction. You can also maybe introduction with conclusions. With the use of part line, the average CPU is reduced. You're going to reduce your performance, of course, because you're going to do it parallelly. Time also can be reduced. 1. Data operand pass through all segments. Second, each segment consists of circuit that perform sub-operation. Third, segment are separated by register, which is R, that hold the intermediate result between stages. So you can see first, this is one segment, second segment, segment until repeating. You have a control unit, and this is the picture of CPU pipeline structure, what you will do. So this is segment, segment, segment. R is referred to your register. So whenever you have the instruction line in your instruction codes, you're going to have a data operand pass through all segments in sequence. You can see you're going to pass it through all the sequence in sequence, and then after that each sequence are separated by register. Register 1, register 2, and register 3, and so on. This is your data in, and then this is the data out. So this structure, you need to know this is under pipeline structure. How the flow from 1 until 3. So example 9. Case 1. You have the control unit, you have two segments over here, which is fetch, and then after that you're going to execute data in and data out. If without pipeline, you're going to see you need to do fetch first. Fetch number 1 under segment number 1. This is fetch, followed by your execute for your segment 1, and then you're going to loop again, fetch segment number 2, and you're going to continue execute fetch execute number 2. After that, if you have 3, 4, 5, it's going to continue like that without pipeline. So you can see it's going to be longer. But with the pipeline, you're going to see your fetch, and then you're going to execute. While you are execute your segment 1, you finish with fetch segment 1, then you can start your fetch for segment 2. And then, of course, you're going to follow by your execute.
It's 17 hours.
For segment 2, and you can fetch for segment 3 and followed by like that. So this is the pipeline model. It's easy for you understand the theory. So pipeline strategy. The process is referred to as pipelining when a new input are accepted at one end before previously accepted input appear as output at the other N. As a simple approach, consider subdividing instruction processing into two stages: fetch instruction and execute instruction. This is no normal flow of your instructions. There are times during the executions of an instruction when main memory is not being accessed. This time could be used to fetch the next instruction in parallel with the executions of current one. Basically, it's just the explanations of this scenario. So you can read and go through it, but this is all I already explained. So parallelly means that instruction prefetch or fetch overlap. This process will speed up instruction execution. See what is the purpose? Instruction and then you fetch, instruction execute, and then of course you have result. This is two stages of instruction pipeline, simplified view. If you have this one is one segment, if you have another segment, of course you're going to start over here your fetch, instruction, fetch, and then instruction, and then execute. You have another one, the third, fourth, and etc. Okay, this doubling of execution rate is unlikely for two reasons. The execution time will generally be longer than fetch time. The execution time will be generally longer than fetch time. A conditional branch instruction make the address of the next instruction to be fetched unknown. So you can see what is the meaning. Let's say you have instruction, you do the fetch. Sometime you're going to do wait until your fetch is finished, or maybe you directly discharge, which is there is instruction or anything. Then you're going to proceed with the next step, which is your executions. The execution time generally should normally longer than your fetch time. A conditional branch instruction make the address of the next instruction be fetched unknown. So you can see this is the flow. Two stages instruction pipeline, which is expanded view rather than this is the simplified view. So you have the wait versions, and if let's say you have a new address, you're going to continue, but basically it's going to be continue like this. Okay. To gain further speed up, the pipeline must be more stages. So you can see. To gain further speed up, the pipeline must have more stages. Let's consider the following decompositions of instruction processing. Fetch instruction Fi. Read next expected instruction into buffer. Decode instruction Di. Determine the opcode and the operand specifier. Calculate operand CO. Calculate the effective address of each source operand. Fetch operand FO. Fetch each operand from memory. Execute instruction EI. Perform the indicate operands and store the result. And lastly, write operand WO. Store the result in memory. So this one you're going to memorize it. What is the task and description? What each of these components are doing. Another example, case number 2. To implement the instruction cycle with multiple stages, you're going to see, wow, there are so many stages in simpler form. Use multiple execution functional units to parallelize the actual execution phase of several instructions. So you can see you have divided into each of the functions. This will be done by F1, Fi, Di, Co, Fo, Ei, Wo. So you have the data in and data out. You have, of course, need to divide it into several segments. Segment 1 until segment 6. And each of the segment need to have their own register. So this is the version of a simplest view. Then you can see it's similar to what happened here. Only that now you need to do the decompose. Last time you only have several steps, which is fetch and executions only. But using the pipeline, you're going to do more stages, which is 1, 2, 3, 4, 5, 6. You need to have 6 stages instead of just having fetch and executions. Now you have stages for fetch instruction, decode instruction, calculate operands, fetch operand, execute instruction, write operand. So then maybe you can do this in parallel. You can do this with parallel, this one with this. So you're going to shorten if you have more stages using the pipeline concept. So over here, example number 11, figure shows 6 stages of pipeline because this is the 6 stages. Reduce the execution time for 9 instructions from 54 times into 14 times unit only. So you can see how many times unit you already reduce by using 6 stages pipeline. So you can see if you have 9, of course it's going to continue. Let's say this is one process. One process taking 6 times. If you continue with 9, of course 6 times 9 you got 54. But when you do the 6 stages pipeline, when you finish for instruction 1 with your Fi, you're going to start the next with D1 for the second step, which is time 2. Then your Fi already empty. Instruction 2 can start the F1, parallelly doing the D1 at your instructions 2 and so on. This one is similar in your laundry scenario. So basically similar. This is just to show you that when you done it continually, you will get only 40 times unit compared to 64 if you continue it directly without pipeline. So assumptions, each stages equal durations. So you need to have assumptions. So you have equivalent 1 second, let's say, for F1. Another 1 second for DI, another second for CO, another second FO, EI, and so you assume that each stages has equal duration. All stages can be performed in parallel. No memory conflict, which is there is no conflict while you are doing this. All stages can be performed in parallel, mean that every single instruction over here can do it parallelly. and no branching or interrupt happen while you are doing all these 9 instruction. uh, Let me go back to our previous slide. Okay, so I already said I'm going to cover this video until pipeline strategy only. Later on in our next video, we're going to cover the new subtopic, which is pipeline performance. Now you're going to find out the equations. Non-pipeline, what is the equation for you to calculate the cycle time, and when you are using the pipeline concept, what you're going uh, to use for the equation. So there is also speed up equation, and what is the maximum speed up also. So before you can proceed to the next video, maybe you can try to look into the notes and try to do it, because there is an example that provided also. Okay, thank you for your watching, and meet again in our next video. Please be safe and bye bye.